Hey guys, this video will be a continuation of the last video, and in this one we will be trying to use the Boyden method to minimize and find zeros in a function with an inequality constraint to solve the 2D Rosenbach function. So this constraint is it's x naught squared plus x1, and it must be less than or equal to 1. And we want to use the slack variable which is a way of transforming an inequality into an equality. And the Lagrange multiplier will use the local minimum and maximum of the function as part of the constraints. And these can be used to find the appropriate slack variables and then create a more in-depth analysis when using the Boyden method to solve the 2D Rosenbach function. So now we will make the Boyden method solve a more difficult problem using a random number generator. Next, we will use a nonlinear constraint, which you can see here. And now we will define the other variable, or the other function that we want to solve, and that is this part here. We will want our result to be a minimized function, and to do this, we want a very specific method of minimization, which you see here. And now that we've created our two-form minimization, we should now focus on accommodating on the bounds around the variables so that we can define our limits and apply our Lagrange multipliers and slack variables. We will define our Boyden method again, but with extra dimensions on the xmax and xmin, and we will use this to determine our limits using alpha, and it will also have the same stopping conditions as the previous Boyden method, whereas the result switch reports 0, it will stop running. And then we're going to define our second function, similar to the one that we used in the last video. And now we can apply our other methods with the Boyden. We apply the Boyden method again with further definitions. One second. And so for this one, we have the xmax and xmin as an array. And this will help us find our functions min and max and further develop the Lagrange and slack variables. And yet again, we will define another Boyden function, and the goal of this one will be to limit the step size. And just like before, it has the alpha limits and other similar variables with the breaks and everything. And then we will define our Rosenbrock function and our constraint with that. Along with the Rosenbrock function, we will also define our gradients, and the gradients are partial derivatives, and we'll also be defining some more equations. And then from these, we will have our local max and our local min, and then we can evaluate the void method with the slack variables. As you can see here. Lastly, we will do our inequality constraint. And seeing as these values are similar, that means that our Lagrange multipliers and slack variables, when applied, work better than our original void method equation. Alright, thank you guys for watching.